Even though I modified this to get rid of the spring and O-ring and all that stuff, this is pointed downwards. It's difficult to pour into a small tank like on the lawnmower. I did design this cap to keep dirt and dust out of there. And that seal ring that goes around this thing is not going to last forever. And it's going to be hard to find a replacement. I now have this to where this little indentation in the pouring lip lines up perfectly with the can. That makes it easier to pour into a small tank like what's on a lawnmower. And then when you're done, put that on there. It keeps dust and dirt out of your gasoline. And then back that off. It's easier on the 3D print and it's easier on the threads on the can. And there's just a regular cap with an O-ring in it for when you go to get gas, so you're not slopping gasoline all over the back of your car or truck or whatever you're using. But when you get home, you want to loosen that so that the can does not pressurize. These cans are allowed to remain under pressure from the gasoline. Mine, given time, fail right along this mold seam. The threads on this can are a buttress thread, and they start and stop in about the same place. And that should be the same on every can. I have 3 of these cans that are identical, and they have to be because the mold is made that way. The one problem I had is that I could not draw a buttress thread in Fusion 360, and I've come up with a round thread that fits in there very smooth. The idea was to design this so when this tightens, it would time with the threads, and this would be directly in line with the can. I played around with this for about a month and trying to get the threads to match up exactly, this round thread matching the buttress thread, and finding something that would print smoothly. And on the pour spout, my first idea was to have this come down to the bed, but then that O-ring was way up in there. So I changed that to where the O-ring sits in here. And I started off with this being squared off. Then I tapered this so you could see that a little better. I changed that to where I've got a bit of a indentation here. And this makes it real easy to pour gas into a small tank on a lawnmower. And the vent hole is right here. Puts air right into the tank. When you're pouring this from the can, the gasoline level is going to be back here anyway. And unless you're trying to empty the can, there's no gulping or spitting or sloshing of gas out through that hole at all. And then I've added this hole. It's a 3mm O-ring that fits in here. It's a little hard to get back out again. And so I put this hole in here, and with a blunt object, and I repeat blunt, you can gently push up on that and lift that O-ring to where you can grab hold with a pair of needle nose. And as long as you have a good O-ring, that will not leak. Again, this took 3 or 4 weeks. I went through at least 1 kilogram of filament, or a whole spool. When I say the threads on these gas cans are identical, that's reasonably true. The only difference is in this one, because I have screwed these things on and off of here a couple hundred times in developing these nozzles. This is real loose, and the threads are polished. And your can, depending on how much this seam has been trimmed, a little bit sticks out, just how much one of these fittings will screw on or won't screw on will be a little bit variable. And that's why I have listed a standard, a little bit loose, and a little bit tight version. I want this to be straight up and down when this is on the can. A little bit looser means it'll screw on a little more. A little bit tighter means it'll screw on a little bit less when it gets tight on the O-ring. Now, this is an old version. I know it's way too loose. I put that O-ring in there. When I screw this on, it turns too far. I have also printed 2 shims. That one is 1 millimeter thick, and this is a 1/2 millimeter thick. If you put a shim under the O-ring, it's just going to move that O-ring closer to the can and cause this to tighten up a little sooner. This one is way loose. I'm going to put a 1 millimeter shim under it, put the O-ring in there. And when I tighten that up, that lines that up with the can just about perfect. That would save you having to reprint your pour spout. Now, the difference between a standard and a little bit loose version, I would expect to be a 1/2 millimeter. The weakness of a 3D print lies in all the laminations that are the result of the printing process, and from here to here is over 1,000 laminations. I have increased the thickness of this to compensate for that and give it strength. Any Neanderthal can go out and break this thing if they just carelessly go banging it against stuff. Exercise reasonable care and this should perform very well. I printed this with PLA. It's a matter of time before I know for sure how PLA will hold up to gasoline. If you don't like PLA, print it in something else. I am told ABS is a bad choice. The files for these will be on Thingiverse under my name. The information for the correct size O-ring that'll fit in here will also be in that listing. With the STL files being available on Thingiverse under the Creative Commons, you can print one or more for your own personal use. Any and all commercial rights are reserved. The design being free to you, the most expensive thing you'll have to deal with is the O-ring. You need one for the gas cap and one for the pour nozzle. I got these from McMaster-Carr. The pack of 10 cost $8.50, and then it was $7 to ship it.